Hey guys, today we are doing 1.7, which is about exact values. So we are going to be calculating the exact value of a given trig function. So before, when we used to have trig functions, for instance, sine of 30, you would type that into your calculator and you would get some sort of decimally answer. Well, now what we want is we want the exact value, because we don't want that irrational number that keeps going forever. We want to know what is it. Is root 3 over 2, whatever. We need to know exactly what those values are. So let's start out by doing, in fact, sine and cosine and tangent of 30 degrees. So whenever you are doing this thing right here, we're going to go ahead and we are going to draw our angle. Okay, so this is 30 degrees. If you're thinking about your unit circle in terms of degrees, that's 90 degrees. That means this guy is over here somewhere, and this is your 30-degree angle. So if I was to go ahead and drop this down and make myself a nice little triangle, a nice right triangle, you're going to notice here, if this angle is 30 degrees, then this angle must be 60 degrees. And hopefully you remember that from the first week of school, because we're going to be putting it all together now. And that this is the special right triangle that's a 30, 60, 90 triangle. Okay, and if we remember our ratios, we would know if the side opposite the 30 is x, the side opposite the 60 is x root 3, and the side opposite the 90 is 2x. Okay, now we're dealing with what we call the unit circle, which means if I'm looking at this guy, any radius on this unit circle is 1. So the side that's opposite right here, we're going to call this one 1, just to make things easier. That's the easiest value we could use. 1 root 3 would be opposite the 60, so 1 root 3. And then 90, that would be 2 times 1 is 2. Okay, again, we're just trying to use the simplest values that we can here. So now if I go ahead and I'm finding those trig values, so sine of 30 degrees would be your SOHCAHTOA, so you would have your opposite over your hypotenuse, which would give me opposite of 30 is 1 over your hypotenuse is 2. Okay, your cosine of 30, same deal, your adjacent over your hypotenuse. So my adjacent right here to the 30-degree angle, remember we're dealing with that angle, is root 3 over 2. And then finally, if I wanted to find tangent of 30, I would take my opposite over my adjacent, so 1 over the square root of 3. And remember, I don't have to rationalize that if I don't want to. Okay, that is the square root of 3 over 3 if you're worried. So that's how we can calculate any of our basic trig values. You can do the same thing if, for instance, you wanted to find like secant of 30 degrees. Remember, you can remember that it's hypotenuse over adjacent, or you can flip-flop your two things, and you would get that that would be 2 over the root 3 if you already knew your cosine. Okay, so that's the general idea if you're calculating the exact values. You notice we didn't get any sort of gross decimals. We got all nice fractions that are the exact values of each of these trig functions. Okay, so let's look at an angle that's not in quadrant 1, like 120. So if I'm finding the sine of 120, again, your first goal is to draw this angle, because if I can draw this angle, I can figure out what its reference angle is and then make that special right triangle. So 120, remember this guy over here is 180 degrees. This would be 90. So that 120 is in between here. Okay, and remember we drew it going this way. So if I'm trying to find my reference angle right here, I can always take 180 minus 120, or you can ask yourself, how far away are these two things? So if I look right here, this angle, theta, I'm going to erase it real quick. Well, you know, erased half my coordinates. Okay, so right here, that angle that would be made with the x-axis is 60 degrees. Okay, that's how far away 120 is from 180. So now I could go ahead and think about my special rights again. So again, this guy's, if this angle is 60, that angle must be 30. So I can draw my 30, 60, 90 chart. Or you can remember that opposite the biggest side is going to be root 3. Opposite the smallest side is going to be 1, and your hypotenuse is 2, the length of that angle. Okay, so then when you're looking in here, you're going to go ahead and then just find whatever trig value. So you have the sine of 60 degrees, which would be the opposite over the hypotenuse. So opposite your 60 is root 3 over your hypotenuse is 2. Okay, and you can do the same thing if, for instance, they asked you the secant of 120. You just look at your picture. Secant is the same, or is the reciprocal of cosine. So you would take your hypotenuse, 2, over your cosine is 1. Now, the one thing that we didn't think about here was the fact that this is now in quadrant 2. So now I have to deal with negative lengths. So when I'm looking right here, you notice you went up to get to this top of the angle. So this is a positive value. Your hypotenuse is always going to be a positive value. We're not going to deal with that. But you went over here to the left to get this 1. So this is actually a negative 1. So you have to worry about your negatives now because you're dealing with this quadrant right here. So secant of 120, if I'm dealing with this opposite side, is actually a negative 1, which would mean my answer would be negative 2. Okay, so you have to look at what your quadrants are as far as, did you go to the left or right? Did you go up or down? Okay, so let's practice one more time with this, with the cotangent of negative 135. Okay, remember if it's a negative, we're going to go ahead and go backwards. And so this guy would be negative 120 degrees. Sorry, 180 degrees. Wow, that was a little bit of a taco. Okay, so negative 90 degrees. So this guy is right here. This would be negative 135 degrees. So I want to find that reference angle. Remember, how far away is 135 from 180? So we went 45 degrees to get up there. And you can always take 180 minus 135 and you would get that 45 degree angle. Well, we know some stuff about 45 degree angles. Right triangles. If I made this into a beautiful triangle, remember this is x, x, x root 2. Remember, we're going to make this as simple as we can, so we're going to just plug in. This one side length's going to be 1, this one's going to be 1, and this will be 1 square root of 2. Now, that's makes your hypotenuse. Remember, that one's always going to be positive, so that's root 2. However, I went to the left right here, so this length is 1, but we're going to call it negative 1. I went down to make that altitude, so this is also going to be negative 1. So in quadrant 3, remember, both of your coordinates are negative, so both of your legs will be negative. So now I can just go ahead and find your cotangent, which is the opposite of, the reciprocal of tangent. So that's going to be the adjacent over the opposite, and adjacent to your 45 is negative 1. Opposite your 45 is negative 1, which equals to 1. So cotangent of negative 135 is positive 1. Okay? So really quickly, I want us to recall, well, we're going to talk about, first of all, I want you to pause, write down these steps. Okay, this is what we did just now in order to find these. We did it with degrees. It gets a little bit more tricky when you're in radians because you have to remember your radian measurements. So the first thing you're going to do, we drew our angle in the correct quadrant. Check. We found the reference angle. Remember, if it's in quadrant 1, the reference angle is the angle. If it's in quadrant 2, then your reference angle is going to be 180 minus your angle, and so on and so forth. You're going to create your right triangle with your x-axis, and you're going to figure out your special right triangle value. So it's either going to be a 30, 60, 90 or a 45, 45, 90. Make sure you fill in your positive and negative values. That's probably the most important part. You have to remember that now we're dealing on a coordinate plane. Okay, and then we find the given the trig ratio for the reference angle. Okay, so again, you paused if you needed to write that down. Now we're going to go and look and remember some of our special angles. So remember that we had that pi over 6 value on our unit circle was equal to 30 degrees. Okay, pi over 6 is usually going to be one of your reference angles. Okay, the other ones that we know are pi over 4 is equal to 45 degrees. Again, we saw that those were one of our reference angles because we're looking for those two special rights. Okay, and then pi over 3, the smaller denominator, is equal to 60 degrees. So remember, we have 30, 60, 90 triangles, and we have 45, 45, 90 triangles. So when you're trying to find exact trig values, you're usually looking for one of those three special rights. So I can go ahead and use those. Okay, so let us look at one of these radian values. They want you to find the cosecant of 11 pi over 6. So our first step is to draw the angle in the correct quadrant. So when I'm drawing the angle in the correct quadrant, remember, I'm going to go ahead and try to label all of my border angles, all of your x and y axis, based on the same denominator. So this right here would be 6 pi over 6. And then if I went all the way around, this is 12 pi over 6. Okay, so 11 is closer to 12 than it is to 6, which means my angle is hanging out over here. Okay, so now I'm going to figure out what that reference angle is in here. So if I say that this is 11 pi over 6, that's pi over 6 away from the 12 pi over 6. So that makes my angle, my reference angle, pi over 6. Pi over 6 is equivalent to 30 degrees. So we're going to be using a 30, 60, 90 right triangle. Okay, so I'm going to make my right triangle. I'm going to fill in those values thinking about my positive and negatives. So opposite my 30 is going to be 1, but look, you went down, so it's negative 1. Opposite my 60 is going to be 1 times the square root of 3, so the square root of 3. And opposite your 90, which is your hypotenuse, is 2. Okay, notice that you went to the right, so it's positive root 3. Now you go ahead and you think about what values you're looking at here. You want cosecant. Cosecant of that angle is going to be I'm just going to call it theta. I'm too lazy to write that. Cosecant is the reciprocal of sine, which means you're going to find the hypotenuse over the opposite. Remember, it's this angle, the one with the reference angle, the one made with your x-axis. Your hypotenuse is 2. Your opposite is negative 1, and so your final answer would be negative 2. Okay? So again, we're not too worried about if we need to convert yet between radians and degrees. That's still a legit thing to do. Next thing we're going to do, please pull out that unit circle and take a second and fill in your angle measurements. Alrighty, so hopefully you filled in your angles. So we're going to talk a little bit about those specific trig values for those angles. So we just found pi over 6. Okay, we did that one. We called it 30 degrees, but they're the same values because remember those two values are equivalent. So we found out that the sine of 30 degrees was the opposite over the hypotenuse, which was 1 over 2. Okay, we found out that the cosine, I am going to move that over, the cosine was root 3 over 2. And so when I'm thinking about this, if I wrote this as an ordered pair, this would be my x value, this would be my y value. Because remember, if you dropped your altitude right here, you'd have that little right triangle. So this is the cosine, this is the sine. We also consider this one the x value of your trig function, and this is the y value of your trig function. Cosine comes before sine, x comes before y, as far as alphabetically. Okay? And so, when I'm looking at this, the last thing I'm going to tell you is that the tangent function is always going to be your y value divided by your x value. And we saw that. We found out that the tangent of 30 degrees was 1 over root 3. And so if I took your y, which was 1/2, and divided it by your x, which was root 3 over 2, did your flip-flop thing, your 2's would cancel, you'd get 1 over root 3. So when you find your tangent, you take your y over your x value. And so that's 1 over the square root of 3. Okay, and so that's true for any of your angles that have the reference angle of pi over 6. Okay, so when you're looking at them, anything that has that pi over 6, so 5 pi over 6, 7 pi over 6, 11 pi over 6, they all have the reference angle of 30 degrees. So when you're looking at it, they're all making that certain special right triangle, the 30, 60, 90, and they're all going to have those same ratios. So if I came over here to my 5 pi over 6, my cosine would be root 3 over 2. My sine would be 1/2, and my tangent would be 1 over root 3. Now, the only thing we talked about was when we had those, the negatives involved, because now we're dealing with quadrants and we're thinking about how would I name a point within the quadrant. So if you remember, if you're going over here towards the left, that's a negative. And cosine is your x value. So cosine goes with your left or right. So cosine in this quadrant is going to be negative. Okay, you still went up, so your sine will be good. But if you take your tangent, which is your y, divided by your x, a positive divided by negative, it's going to get you a negative. So in this quadrant, you have only your sine values are going to be positive. Okay, and we have a cute little saying for this. Let me get this erased in here. Okay, you can just write it in the corners, it's fine. So when you're thinking about your quadrants, I just wanted to make this less messy. So when I look in here, when you have your trig values, in your first quadrant, in quadrant 1, all of your exact values are going to be positive because you're going up, you're going to the right, those are both positive values. Over here in your second quadrant, your only value that's going to be positive is going to be sine because you're going to the right, you're going to the left, which makes it negative. Okay, down here in this bottom quadrant, you're going, in quadrant 3, you're going down and you're going to the left, which makes your cosine negative and your sine negative, but then your tangent, a negative divided by negative, is going to be a positive. So this only positive value will be tan. Okay, and then finally, in this quadrant, you're going down, so your sine will be negative, so your tangent will also be negative, but then you're going to the right, which makes your cosine positive, so only cosine is positive here. Okay, we have a little saying for that. I learned it as all students take calculus. So in quadrant 1, all of your sine functions are positive. In quadrant 2, only sine. Quadrant 3, only tan. In quadrant 4, only cosine. Okay, and so all students take calculus. We are going to finish filling out our unit circle in 1.8 as far as putting in the rest of our ratios. But I did want to talk about these special angles up here. They're called quadrantal angles or your border angles because they don't follow quite the same rules. Okay, so grab your piece of paper back. We're not on our unit circle anymore, and we're going to talk about our quadrant border angles. Okay, so I don't know why sine of 120 is hanging out down there, whatever. Quadrant border angles. So when I'm thinking about those angles, there's a couple ways we could do it. So the first thing that you think about is when you have these coordinates out here. If I have a unit circle, this coordinate would be the x is 1, the y is 0. This coordinate would be this guy is 0 for the x, 1 for the y. This one would be -1, 0, and this one would be 0, -1. If you remember, we said that the x-coordinate is cosine, the y-coordinate is sine, and then to take tangent, we find the y over the x. So when I look at this right here, if I was to find the angle measures in here, so this is super small, so this guy right here would be 0, this one would be pi over 2, this is, pi, 2 pi over 2, or 3 pi over 2, and then this is also 2 pi over here. So if I was to think about it that way, if this guy is my x-coordinate, then my cosine of 0 or my cosine of 2 pi is 1. My sine would be 0, and then if I take my y over my x, I get 0 over 1, which gives me 0. So tangent is 0. Okay, then I do the same thing up here. Now my cosine, here, let me label that. Cosine, sine, tangent. Same thing here. My cosine now is 0. My sine is 1. And then to find my tangent, I'm going to take my sine over my cosine. So I have 1 divided by 0. Well, we can't divide by 0, which makes my tangent undefined on that y-axis. Okay, over here, same deal. You have your cosine, your sine, and then to find your tangent, you're going to take your 0 divided by -1, which just gives you 0 for tangent. And last but not least, this guy 0 would be your cosine of 3 pi over 2, your sine would be -1, and then your tangent would be -1 divided by 0, which is again undefined for tangent. Okay, so that's something you can think about if you want to think about those points. We also have a cute little saying, and it goes, O, I, O, I, O, you. Oh, I don't owe. I don't owe you. Sorry, I put a 1 there. I don't owe you. Okay. Oh, I put my negative in the wrong spot. That's why I got confused. I tried to write 1 twice. Okay, so O, I owe you. Oh, I don't owe you. And so this makes a little chart. This is going to be your sine, your cosine, your tangent, okay, and then these are your angles. So this is 0 degrees, this is 90 degrees, 180 degrees, 270 degrees. Okay, and remember that 0 and 360 are the same thing. If I was to put in my radian measurements, then this is 0 or 2 pi. This is pi over 2. This is pi, just pi, and this is 3 pi over 2. Okay, so this makes a cute little chart for you. So if I was to look in here, I'm not going to put my other lines in there since I apparently can't draw straight lines. If I look in here and I was trying to find specific values, for instance, I wanted to find the cosine of pi, I would go to my cosine. My pi is my 180 degree angle, and I'd find that that was -1. Same thing that we found over here on our coordinate plane. Okay, if I wanted to find the cosecant of pi over 2, remember that's the opposite of sine, the reciprocal of sine. So I'd go to sine, I'd go to pi over 2, that's 1. Okay, so that'd be 1 over 1. Okay, secant, 3 pi over 2. When I look in there, secant is the opposite of cosine. So when I go into cosine, go to 3 pi over 2. Down here is 0. So when I find that 0, remember I flip-flop it. So I have 1 over 0. So that's undefined right there. We can't have a value at that function point. Okay, and it works the same for tangent. So for instance, you were going to find the cotangent of 90 degrees. So tangent and cotangent go together, so we have 90. This is undefined. So you might think it's undefined, but remember, in order to get to the undefined, we went 0 over 1, right? Or 1 over 0. Well, if I flip-flop that, that's just going to get me 0 over 1, which is just 0. Okay, so they kind of flip-flop when you have your other angles. Okay, that is all I have for you today. I know that seems like a lot, and I know the videos this week were pretty long. These are some of the essential things that you're going to have to remember and memorize and do all your exact values for. We will continue exact values over the weekend, so if you're still a little bit lost, don't stress too much. We will have plenty of time to learn some more exact values. See ya!